My name is Maggie Duerr. I am actually the math department chair here at Orange Lutheran High School. This is my 31st year teaching here. I currently teach Honors Pre-Calculus, AP Calculus A-B, and also AP Calculus BC. I can definitely tell you fun student stories. I build kind of throughout the year to what I call my box of fun. Sometimes students do not think word problems are fun, but if you've ever worked with angles of elevation or angles of depression, they typically have some reoccurring themes and items. So I tell my students that I have a box of fun. For example, the students are obviously able to draw in the same space, but a typical problem would be finding the height of a building, to automatically have a building to pop up there and then draw in the appropriate angles of elevation, horizontals or verticals, or be able to solve for whatever they want or whatever's needed in the problem. I have quite a few in terms of a variety. Of course, we have airplanes, we have boats, we even have lighthouses, we have ships. And we made these as a department a few years ago. Everybody has a classroom set that kind of fits all the different problems that you might see when you work with angles of elevation and angles of depression. While students are really good at using online tools and apps, physical models are a really good way for them to connect an understanding of ideas to the actual math vocabulary and symbols. These concrete models really bring math alive for the students and help them to visualize a problem in addition to solving it. Another way that I get to use my box of fun is with my AP Calculus classes when we work through volumes of rotational solids. They work through what are called disk method and also washer method. And the idea for them is that they would be able to visually see, when you're working with a rotational solid, you could work with cross sections that are little washers. If you put all those washers together and added them up, you would actually have a solid. So the formulas are related and they can see the difference between a disk, conversely, with when they get to rotational solids that have a hole in the middle, like a lifesaver. Now the cross sections are not disks, they're washers. They add up all the different washers volumes, they would have a rotational solid. So I tell them all year long, we have a box of fun. They end up with getting fairly humored by the different things that they can then go and find the volume of. If you've ever gone to the grocery store, if you had a function that can define the side of your pineapple, you can find the volume of your pineapple. The other last thing in this chapter that's in our box of fun is sometimes hard for students to see on a piece of paper something that is three-dimensional. So we're able to illustrate an exact problem, a model that I've made ahead of time, of a solid that actually has cross sections that are perpendicular to, in this case, the x-axis. These are obviously squared. The geometric shape may change, but this gives them a visual rather than trying to just think about this on a piece of paper, which is an application of integration. So the box of fun is a very important tool in my classroom, and I hope it brings fun for the students. Thank you so much for spending some time in my classroom and seeing how I use a box of fun to make learning just that much more interesting for our amazing students. God bless your day.